Uh, I'm Pradeep Gowda. I'm from Indianapolis. I've worked there, lived there, go to school there. Um, I've been using Python for more than 10 years now. 2000 is when I started using Python. I think it was 1.5.2 or something. So it's been a long while. But as with any technology, after some time you start feeling a little insecure about it because all the new kids on the block. It's like when I started doing professional programming, the first framework I used was Zope and Plone. So yeah, if you know Pythonistas, it's like it's another neighborhood where they don't go. Some of them do, but a lot of them don't. So from that, I moved on to Django, blah blah, whatever. But now it appears as if Python itself is in a cycle of where the cool kids are no longer using it and blah blah blah, whatever. So the main reason, one of the main reasons given for that appears to be this whole the Node.js and other frameworks. Okay, and then even I had these questions. So what makes it so appealing? Why is it everybody so worked up about it? When Ruby on Rails happened, I was like, well, there's nothing in Ruby on Rails which I can't do in Pylons or Django or other frameworks. But Node.js, the hype cycle seemed to be much more stronger and all pervasive. So one of the biggest words that is thrown around when it comes to Node.js is this word called asynchronous and web scale and non-blocking. Many of you might have seen this. Okay, you might have seen this video. If you haven't, then please go and watch this. I'm not hating on Node.js. In fact, I think it's a very interesting framework. It has, as a platform, it has brought a lot of new ideas, and also it has the benefit of not having a lot of old cruft to deal with. So it's essentially a new framework. So it allows you to take the best of the existing frameworks and languages and build on top of it. But then once again, I mean, when you put a cream on top of something bad, anyway, it's still bad. The JavaScript language itself is not really something great, but it is the framework is interesting because of the amount of libraries that are being written and essentially the asynchronous thinking that people are using to write most of the new libraries. It's not that you can't write asynchronous or non-blocking web scale code in other languages. It's just that a lot of cultural baggage exists in other languages, including Python, to think that way. So I went around to look at, as a Python programmer, what are my options? How can I use Python, still use Python and do async programming? I knew about Twisted. I had looked at Twisted probably, I don't know, maybe 8-9 years ago, or maybe a little later than that. But then the code looked very weird. It's very similar to the reaction people have when they come in contact with Zope 3 and ZCA. So it's a weird land. It's a different land. And they don't speak the same language as you do. And then you need to know a lot of new words before you can make sense of that. But anyway, so there's nothing new under the sun about async. But it's just that the amount of programming around async and the amount of conversations around async has been increasing dramatically in the last couple of years, especially spearheaded by Node.js and their friends. So what is web scale? In fact, if you go and search for web scale, probably the first link or the paper that will be referred to is this C10K paper, which basically says that to be called like web scale, your program should be able to handle 10,000 concurrent connections. I came in contact with this paper when I was looking at this whole Erlang, MochiWeb, YAS server benchmark. So they use this benchmark as this paper as a benchmark against which they want to measure their server. And this paper basically lists down a lot of ways of achieving that kind of performance. Traditionally, the way to achieve concurrency is threads. Probably that's the first lesson in any concurrency class that you will learn. But thread traditionally has been very difficult to understand. In fact, it's difficult to implement. You have to take care of resources yourself. You have to manage logs, all that. So unless you're really doing system level programming where threads are your best option, people avoid using threads. And yeah, so we'll talk about that later. And then, of course, number 2, it has to be Buzzard compatible. So that's the. So is that the solution? That's what I was afraid of, that I have to do more JavaScript. I do JavaScript. I use on client side, but I was not sure whether I wanted to write server side stuff in Node. So that was my reaction. And yeah, I mean, everybody has seen this video, and it's not really a rag on Node.js as much as it is on people's propensity to follow bandwagons without really considering what's going on. Anyway, so let's get back to this C10K paper. So one of the side effects of going with the fad is that people tend to forget that there is a multiple there are multiple layers of systems that work to make any system performant or to do what you want it to do. So people forget the OS most of the time. So unless you really know what the OS is providing you, anything you built on top of it is going to be just a cargo cult. I mean, you are just doing that stuff because someone is telling you to do this. So you need to really go back to the C10K paper if you're really interested in this to understand what are the different mechanisms. So some of the outlines are something like this. So traditionally, when you talk about threads, one way to handle multiple clients connections is to have one thread per client. But then that's not very efficient because you end up running out of resources very fast. I think on average you use something like 2 MB. Let's say you use 2 MB per thread per connection. On a 32-bit machine, you might run out of memory very fast. But that may not be a problem in the coming, already existing 64-bit systems. But of course, people are still reluctant to write thread-oriented programming. That's the traditional strategy. The other strategy is to use one thread for a lot of connections. And there are a couple of different varieties of doing that. The traditional ones have been select and polling. The other strategy is to use a wrapper around that. It's KQ on BSD systems and ePOL on Linux kernels. And the third one is using asynchronous I/O, and M:1, M:(n) is basically the one thread per client strategy, but that uses blocking I/O. Basically, when you use a separate stack for each connection, you end up running out of space. That's the traditional model I was talking about. Or build server code into kernel. This has been done in Linux kernel. I think there is a static file server called Tux, which actually is very fast, but then you're actually hacking kernel to write a web server. So that may not be the most programmer-friendly way to do it. So, of course, when you talk about Python to anybody who is not a Python programmer, the first gotcha is always the white space. Oh, how do you tolerate the white space? The first and the only Ruby meeting I went to, I was really pissed off because the only thing that they had to say in welcome is, oh, white spaces, we can't tolerate that. Oh, thank you. We are a very, very welcoming community. Anyway, it's just a personal peeve. But the second monster when it comes to Python is, oh, the GIL, the global interpreted lock. You can't do anything because there is a GIL and it's not scalable. You know what? Even Node.js uses a single thread. Okay, and then of course it's evented, but it is still a single thread. Okay, so we can do the same thing in Python too. But we'll look at what are the different ways of doing that. So what does the GIL mean? It basically means that the GIL, with the GIL existing, a Python process can use at most one CPU core for running Python code. So that's what it means. And then what's a thread? It's an execution unit scheduled by the operating system. And then a process is basically a bunch of threads which share the same virtual address space, file handlers, and signaler handlers, and permissions, etc. So this is the basic terminology. you're looking at. So let's get back to Python. We talked about the C10K problem and a couple of standard ways of handling that. So when we talk about Python, typically we implicitly mean it's C Python. Okay, but Python is a language. C Python is the most popular implementation. But we should always separate the two, especially when it comes to the topic we are discussing today, because the GIL goes away if you're using Jython. If you're on JVM, there is no GIL. Okay, so I mean you have to remember that. And of course, there are other implementations of Python like Stackless, which are explicitly written so that you can have a lot of concurrent connections. In fact, this has been a solved problem in the Python ecosystem. Second Life, I think they are the primary developers behind this, and they have been using Stackless approach for many years now. In fact, if you go to PyCon, Linden Labs, they are one of the biggest sponsors, and they're very active Python contributors. And so it already works. I mean, Stackless is already a massively concurrent system. And then of course there is Jython and JVM. The latest on the JVM system, inspired by this whole asynchronous non-blocking thing, is called Vertex.io. I didn't have enough time to really understand how that works, but probably that's another talk. So there are a lot of options if you look beyond just CPython. Of course, even on CPython, you can do asynchronous programming and non-blocking code, but depending on what your platform is, depending on what your infrastructure is, and how free you are to choose one of these, you can look at other options. You're not tied to CPython if your problem is web scale. Okay, and then the ecosystem and the culture. So your sysadmin may not allow you to install Stackless on your system, so you're stuck to CPython. Or your company uses only Java. Well, actually, that's a whole different problem, but you have to convince them to use Python in the first place. But anyway, but still you have options. This link, I would even call it as a very informal paper because it does a very good job of listing the options, asynchronous servers in Python. So I've not taken all the examples. I've only taken a few examples here. The top header is basically the different method, the different approach to do asynchronous programming, and you should definitely visit this page to see the benchmarks and to see the code. A lot of code I've taken from this page, so that I mean it's well documented, so I'm using that. So let's look at the different approaches. There is the callback approach. This might be familiar to you if you've done any kind of desktop programming, especially Java Swing programming. This is very familiar to desktop programmers. And then you have the async approach. Okay, callback. So Twisted has been using callback programming style for a long time. Then there is the async style that's made popular by Tornado, a framework from earlier FriendFeed, now Facebook. And then the generator style. This is actually very, generator is pretty intuitive to Python programmers because we use generators in regular code, and the code doesn't look weird. So it feels much natural. Then there is the coroutine style. In fact, the coroutine style is also used in both, even in the gEvent and eventlet frameworks, but Chiral is one framework which uses only coroutines without using any of the other methods. We'll come to all of that individually, but this is the gist of the survey of frameworks that we're looking at. So this is the typical blocking synchronous I/O. This is how I would program if I'm not thinking asynchronously, or this is the default mode of writing code. Okay, so that is, let's say I want to query a database, and then I want to do something with that. So this code can be, Django or Pyramid or Flask. It's a very standard block of piece of code which queries the database and then returns the results. So if the database server takes 2 seconds, well, which means basically you're not indexed your tables properly, but let's assume that your database actually takes 2 seconds. So that would mean that you are serving 30 requests per minute, or like more standard way of saying that is 0.5 requests per second, which is really, really bad. Okay, so that's one way to do it. The standard way, unthinking, intuitive Python programmer way. I would probably write code like this all the time. So the asynchronous I/O way is slightly different. So what I'm doing here is basically the query function is slightly different. So I'm passing another parameter of this function called onResponse. That is, instead of me waiting for this query to finish, I'm saying, go ahead and execute the query. But once you finish, you call this function with the result you have. So instead of me waiting, I just give the job to you, and then you come back when you're ready. Okay, so that's the difference. That's the non-blocking asynchronous style. So onResponse, that is this function, we get the response, and then we do something with it. So fundamentally, there is not much difference, except that instead of having one function, which is our natural way of writing code, we have to write a callback function which receives the response and does something with it. So once again, this async with callback method, popularly used by Twisted, uses a single thread. Then so it does async I/O operations, whether it is a database or whether it's a web request, anything that takes a long time, or at least in computer time, it takes some time to finish. And then for each I/O operations, give a callback function to be called back when the operation completes. So we saw the code for that just before this. And then this I/O is, if you see this pattern will repeat again and again and again. In fact, you'll see that word libEvent and libEv in a lot of places in this presentation. So nobody writes their own I/O framework. So almost all async frameworks, whether it is Node or Lua or Python, all of them use one of these frameworks, either libEvent or libEv or libuv. I haven't mentioned libuv because, I've been reading about all these frameworks. It's like a big ball of mud. I don't know how it all connects. And then finally, when I was making the slides today, just 30 minutes ago, it connected that libuv is basically a replacement for libEvent. If I had known that, I would have probably included that here. But fundamentally, it all boils down to your language using some of the language features to unblock code, that is pass on control when it is waiting. And then there is an I/O framework below, somewhere in the OS level, which actually waits till that particular channel is full, or that the callee is ready to give you something, and then tells your program, okay, this is your data back, take it. So there are two parts to it. One is how your language handles it, and the OS level. So the libEvent and the libuv you will see many times over, because that's the underlying framework. It's actually a C library, and once again, libEvent and libuv abstract operating system idiosyncrasies and things like that, Windows, BSD, Linux, but they are the backbone for a lot of these frameworks. But the problem with async code is you'll end up with spaghetti code. That is, this is especially true if you have seen standard Node.js code. I couldn't find a good Python code for this presentation, but that one thing that really disappointed me with Node.js code was that there was so much of callback code. You have a function, and then you make a function call. Let's say you say, go and fetch this page, and then on return, pass this to this function, which parses it to do something. So all that is actually one function call. You have one function. In the parameter, you are passing the URL, on the other parameters, the another function, you are writing that inside the function call, which is very difficult to understand, very difficult to sort of keep track of what's going on here. So that's the problem with any async callback style programming. Yeah. The one thing with Twisted is it's not really just about writing web applications. Actually, people use it for a lot of other things. You can it basically separates out protocols from you have the protocol, and then you have the I forget the name anyway. So Twisted is actually much more of a framework than just a web library. Okay, so it can do a lot of things apart from HTTP. People have used it for writing email servers and FTP servers and IRCs and things like that. So this is how a Twisted code looks like. So there's a lot of words here that even I am not very familiar with. Because, for instance, look at what's a reactor. What does a reactor do with my code? And what's a protocol? And what's a transport? Yeah, exactly. That's the word I forgot. Transport. It separates out transports and protocols. So then there is a socket. Then there is a TCP. Why do I need to know even about TCP? Because isn't all of my code on TCP? I mean, does anybody use UDP? I mean they do, I know, but but when most of the time you're doing web applications, you don't even think about these things. For you, it's all HTTP. That's the protocol, and then the transportation layer. I mean, it's TCP. That's all you know. You don't even think about TCP actually. All you need to think about is HTTP. So Twisted goes one level above or below, depending on how you look at it. So it exposes more things to you in different words. So the code looks weird when you start writing Twisted code. So it takes some investment, but this has been used very successfully in a lot of big name companies. I was surprised to see that one of the airline booking companies, Canadian booking companies, they use Twisted. So it must be serious. So if they're using in airline booking, it's pretty serious use. I'll not go into the code much. There's nothing special. Yeah, Tornado, this is probably a much more friendlier framework for someone looking to adopt a new Python web framework with an eye towards asynchronous programming. So this was built by FriendFeed. It's interesting. I think it's important to note why FriendFeed built it. If you have used FriendFeed, anybody has used FriendFeed? No? I used to use FriendFeed. I think I still have a profile which I don't visit, but it was pretty cool. I mean, it was the Facebook wall before the Facebook wall for geeks. It worked pretty well. I mean, I think that's the reason why they were acquired by Facebook anyway. So it's a lot of real-time interaction. FriendFeed would basically pull your feeds from your blog, your Twitter feed, and Delicious, and your friends' activities in all one page, which is basically your friend Facebook wall, right? And then it would show it on one page. So you can see a pattern there. It's a lot of small data in rapid succession. I mean, a lot of things happening at the same time, but they're all small pieces of data. It's not like you're streaming a movie. That's a completely different use case. But this is small chunks of data, a lot of it. Okay, so that becomes important when we start looking at looking into this. What is the payoff between something like ePoll and select, things like that? So that becomes important. The size of data becomes important. But let's ignore that for now. Once again, it's non-blocking. That is, if you have a long blocking call happening, then you can just say that, okay, call me back when this is ready, and Tornado will take care of it. I think the code is much more interesting. Oh yeah, the IO loop thing is important. Once again, there is only one IO loop per your application. So that's basically like one single thread. okay, running the entire thing. I mean, the typical application actually doesn't look like this, but this code exposes some of the sockets. When I pasted the code, I think the formatting is off. Sorry. I'll just pass this. I think also I'm running out of time. So, yeah. I think we have to look at some of this code just to show that writing code that uses a C library in the background, an IO framework is not all that magical as it appears to be, because as a Python programmer, I'm very suspicious of having to call C code because it's a different world. I mean, I can do C programming, I can do Python programming, but just don't ask me to mix these unless they are talking over a HTTP port or something. I can understand that, I can deal with that, but not library calls. Anyway, that's my own little phobia there. But when I looked at this IO loop code, it didn't look all that scary to me at all. It's actually very approachable code. Basically, what this code does is it maintains a list of open connections. I think I don't have time to do that. So, and it maintains a list of callbacks that it needs to return. My fear was I didn't have enough material to actually finish the talk. Looks like looks like I should have. Okay, thanks. Yeah. Okay. So going to the underlying mechanism. On Linux, it uses EPOL, and then on BSD, it uses KQ. Once again, that is coming through the lib event library. So you can actually, if you want to write your own framework today, perhaps you can just piggyback on lib event or libuv instead of thinking how to do whether you have to use a framework. For instance, I like Tornado because it's async, but I can't use Tornado because it doesn't allow me to use my other familiar tools like Jinja templating and things like that. So, but after looking at this, it looks like I can actually extend Tornado, to do all that myself. If I have time, I'll probably show you a code which basically converts a synchronous library to access database into asynchronous code with the same techniques. So. Yeah. So EPOL is basically the notification mechanism built into the Linux kernel. This has better performance over the standard POL when the number of vast file descriptors is large. Whenever you open a new socket, you get a new file descriptor. So when the number of active file descriptors increases, EPOL has a better performance compared to the the standard POL interface that we are familiar with. BSD has a comparative interface called KQ. If you are using a library like libevent, that's chosen for you automatically. You don't have to specify that. So, okay, I think this is interesting because I was talking about asynchronous style programming. Has two parts. One is the language, other is the IO framework. So this is a good example of using Python language features. That is, you're using a yield statement. You're actually returning control at this point to the calling program. In fact, you can have many more yield statements, and the function can have multiple entry points, and you can return. Let's say you have multiple pieces, and each piece takes, has some delay to it. You don't have to wait till everything is complete to return the values. You can yield when you have the first chunk, and then you can use second yield to return the second chunk and things like that. So that's a good example of a generator style. I'll pass this. Okay, stackless. So this is basically a thread-based programming without having to know about threads. In fact, it uses different words, so you don't even have to have that fear about using the same locks and threads and all these keywords. So basically, tasklet is an alternative to threads and processes, and then it is not really concurrent in the thread sense, but it does allow you to have a lot of concurrent connections, and it allows you to exchange data between all these different threads, pseudo threads, using channels. And Stackless has in turn inspired, but of course Stackless is a different implementation of Python, so people don't want to use that. So they took the interesting bits from Stackless and they called it as Greenlet. That's a library that you can use with CPython. So let's see what happens here. So this is actually an example of factorial where you're making recursive calls, but if you do it on standard Python, you'll blow the stack because the stack, the depth is too high. So what Stackless does is, this is the important part. There is a lot of wrapper code here. That's not important. What's important here is you're creating a new tasklet, essentially a pseudo thread for each call. So we are not using the stack to maintain the execution point. So that basically allows you to overcome the limit of the stack. So Greenlet's tasklets on CPython without implicit scheduling. They're essentially coroutines, and that's a definition of coroutine. Coroutines are computer program components that generalize subroutines to allow multiple entry points. We saw that with yield. I think I'll skip eventlet because gevent is anyway the more interesting and probably the more performant of the two. So it's once again a networking library that is very popular. It uses libevent, actually libev in the recent versions, but it's more probably familiar to Python programmers than eventlet because it's the API is closer to the Python standard lib conventions. It's also highly performant. People have rewritten or ported their code over to gevent from eventlet. Okay, so this is the code I wanted to show. So this is a library which basically wraps the standard psycopg library to become asynchronous. Not all parts are important, but let's see here. So the update handler code, this is interesting. So when psycopg says that it is okay to poll, that is when it says the result is ready, then you actually call back the function. You basically say, okay, now it's time to call back the whatever callback function that was passed. So instead of blocking, basically in this part, you're waiting for psycopg to come back and say the status is okay, now the results are ready, so the channel is ready to be read, and then you're basically calling the callback to deal with the data. You can see that it's not a big chunk of code, but it's wrapping a synchronous library that is psycopg into async style in like 170 lines of code. And the difference would be in your code. I mean, this is the code that is using the new async library. What the programmer has done is basically used it as a decorator. So your code is not changing. In fact, your call is the exact same. This is the standard DB API call. That's not changing. Using a decorator, you're basically converting that into an asynchronous call. So essentially, the problem with async in Python is not the language, but it's more about the culture. Because, for instance, we just saw that psycopg is written in a synchronous manner because, well, that's the norm. That used to be the default style. So some people think that it's actually a good idea to actually abandon the whole language, move on to a complete new language, because the library that they want to use doesn't exist in the new language. But I think I would rather write that myself than probably send a patch or have a derivative of the synchronous library in asynchronous fashion. But anyway, you don't have to do that. You can still use Python to do your async thing. And of course, I didn't talk anything about PyPy2, which is supposed to be not supposed to be, it is the faster implementation of Python. But haven't seen any benchmarks that use PyPy2 with asynchronous. I don't know whether that actually has any impact on the asynchronous performance, but I'll be really interested to see. So this has been more of this talk has been more of, I want to discover this and then share with people what I know, instead of I'm an expert in this and then let me tell you what it is. So I think I learned a lot, and I think there is a lot of things that we can do in Python for asynchronous programming without throwing out the the whole framework and the ecosystem that we have built around us. I hope this served as it's like a peek into the whole ecosystem around asynchronous programming. Thank you. If you have any questions, I'll take. Okay. All right. So, any questions? Yeah. So far I've been like, once again, sure. He asked me whether is there any method that I prefer to do asynchronous programming. So far, I have, once again, I've been doing cargo cultism because I was afraid of the whole async. I thought it was something that is sort of exclusive to Node.js or some other cool technology, and I can't do in Python. So the only approach to asynchronous programming has been using Tornado so far. So I've used only what Tornado has exposed. So for the sake of this talk, actually I went deep into it and then started looking, what is it really? I mean, then I come to realize that ultimately it all depends on a handful of core IO libraries, and then a few language, leveraging the language syntax to do it. As you saw, I didn't have time to show all of it, but the same concept, the same asynchronous thing is done with different methods. Some people use generators, some people use coroutines. In Twisted, you saw that they're using callbacks. There is no use of things like yield and generators. They're using straightforward callback functions as callbacks. So there are different ways of doing the same thing. Yeah, that answered the question. I haven't been doing async programming. I've been doing Tornado programming. Sure. Oh, okay, sure. If you have any more questions, I'll go ahead and answer that. Till then, I think I can show some of this. So once again, see, this is the coroutine, the pattern. So this is actually an example from David Beasley's coroutine talk, actually. This is, in this program, is actually reading, is pipelining a log file and then matching a pattern and then printing out or yielding only those lines, which is basically asynchronous. You are not actually parsing the entire log file, which may be like 50 GB, and then finally giving out one big chunk of lines. So what you're doing is, I mean, this pattern is very familiar to us. We understand what this does. I mean, if some condition is satisfied, then you yield this. And then wherever you're calling, where is grep? Yeah. So this is actually a generator. So when you do this, every time you consume that line, you're basically, the execution is going back to this function and it's going to continue where you left off. So it's like, it's a lazy evaluation. It's a generator pattern that is known to us. Right? All right. So the question is, how do you handle errors in this? Um, I don't know. I mean, as in, I don't see how that's a problem. Maybe because I've not actually.
I mean, like, so like, I guess it's more for asynchronous type of processes. So like, if you send off asynchronous process and it fails, how do you typically
Right. So you have a, let's say you're doing callback cell programming. So the result comes back, the result may be an actual result or it might be an exception. So the callback function should know how to handle that. So, yep. Yep. Error backs. Oh yeah, yes. I mean, I just read that. Haven't used it. So error backs. Yep. Yep. All right. I guess that's it then. Okay. Last question. All right.
How do you feel about like queue-based workflows using like asynchronous processes?
Oh, something like Redis or RabbitMQ. Well, I guess the thing with that is most of the time when you use RabbitMQ or Celery, especially, right? So what you're trying to do is also retain some state. So if you're just doing queues, as in, I mean, you can just use standard Python queues, but most of the time, the reason people use Celery is they want to pass on a state, some code or some data to the next stage. What they want to do is basically hand off the data to another process. So yeah, I mean, that is asynchronous programming too. But there you are using another agent, like a queue, I mean, external queue. So, yep. Okay. Yeah. More questions? Or you want to clarify that a little more? Was I clear? Okay. All right. That's it then. Thank you.